Hello students, welcome back. I am Rinkesh sir, and our today's topic is representation of AC current and voltage by phasor, also called as rotating vector. So represent phasor vector. First, let's see what a phasor is. See, phasor is a vector which rotates about its origin with angular speed omega. So I can write down as it is a vector which rotates about the origin with angular speed omega. Okay, so see if I'm drawing it here graphically. Okay, so if I represent the voltage vector with a black line, let's say this is the vector for voltage V, and let's represent by blue line the voltage vector I. This is the vector I. Okay, this is the condition when only resistor is connected. Okay, means in that time both voltage and current will be in the same phase. Okay, so this angle theta will be equal to omega t, or I can say t1 at any time, t1 t equal to t1. Okay, so now I can split into two components. Okay, see the vertical component here, the vertical component. Okay, they are the sinusoidal varying quantities of V and I. Means this will be this. Okay, that is I sine omega t1, and the vertical component of voltage vector, this value, this will give us V, so not I am sine, this is Vm sine omega t1. Okay, so this vertical component gives the sinusoidal varying quantity of V and I. So I can write it down here. Vertical component of V and I that gives sinusoidal varying quantities of V and I. Okay, means if the angle theta will be 90 degree, then we will get the value as maximum voltage Vm and maximum current Im. Okay, so now if I draw it again in the form of graph, now see when omega t1 is 0, voltage V will be 0. When omega t will be pi by 2, voltage will be maximum. Okay, so let's say this is value at maximum. Okay, when again it will be pi, it will be 0, then it will be in opposite direction, so on. So the corresponding value of this voltage is this at time t equal to t1. Okay, so this is omega t, and omega t is 0, voltage is 0, pi by 2, voltage is maximum. Okay, pi, it's again 0, 3 pi by 2, again it's maximum, but the polarity is opposite, so it's minus Vm. This is the value Vm. Okay, means this is maximum voltage Vm. This will be minus Vm. Okay, now if I represent the current vector, okay, then it will be this way: maximum at pi by 2, this way. The represent corresponding value, this will be at time t1, and this it's the maximum value Im. Okay, and this will be in the opposite direction minus Im. Clear? Now see the magnitude of phasor V and I, that will be giving the amplitude, that is the maximum. Means if I take the magnitude, means this to this, that we will call it as magnitude of voltage vector. Okay, so magnitude of phasor V and I, what will it give? It will give the amplitude, or I can say the peak value, means the maximum value Vm and Im, peak values, that is maximum voltage Vm and maximum current In. Okay, now see the figure that I have drawn, that is the case of resistor. For resistor, V and I are in same phase. For only resistor, means only if only resistor is there. Okay, if only resistor is there in the circuit, V and I, means the voltage vector and the current vector, both are in same phase. Okay, and the phase angle between voltage and current is 0. Although here you can see theta equal to omega t, but the angle between the voltage vector and current vector is 0, means both are in same phase. That is the phase angle between the voltage and current vector is 0. Okay, so this was about representation of AC current and voltage by phasor. This is a specific case when resistor is connected in the series. Okay, so just note it down. Okay students, so that's it for today. Thank you.